Okay, ladies and gentlemen, we're going to look at one last problem for today and just focus on the calculator parts of it. It's going to look familiar as the other ones. It is the 2017 number 2 question, and you'll see why I chose this. It's going to be a totals equals starts since out problem. A certain grocery store has 50 pounds of bananas on a display table when it opens. That's going to be our start. That's probably going to give me a rate of stuff coming in. Let's see, remove bananas. So this is the rate out. Is of these, and you can see they have it in T. The next part, and you can look in your packet, is the rate in, where G of T is measured in pounds per hour, and T is number of hours after the store opens. So it said how many pounds of bananas are removed from the display during the first 2 hours that the store is open. So I got a little ahead of myself here, and what I did is I went to and you can do this in multiple ways. Let me show you how I did it. I went to the calculator, hit the tab button, and in the calculator I added the first function. Ooh, that looks wrong, doesn't it? That should be 10. I get the right answer is the question. Okay. And the second function, tab. Click on the page, hit the tab button. Oh, tab. There it is, 3 plus 2.4 ln, parentheses, x squared plus 2x. I changed it to x's so I can put it in the grapher. 10 plus 0.08x times sine x third. Okay, I have that right there. So now if I go to my calculator page, let's find, I don't know why that worked. Hold on. Oh, because it was off by a decimal point. Remember, I had a number wrongly before, so I did the integral from 0 to 2 of f1 of x, and I got 20.05, because that's the number of bananas going out. So the question says, how many bananas are removed from the display table? The answer is, how many pounds of bananas? We want the thousandths, 20.051 is the correct answer. Hold on. Oh, for that part right there, because it was during the first 2 hours. Next says find f prime of 7. Guess what I'm going to do? I'm just going to find f prime of 7, which prime just means take the derivative of something. So I go back to the calculator. Okay, if I want the derivative of f at 7, f is stored in f1. So I'll go menu, calculus. And I can do derivative at a point, because that lets me know when I have the derivative right there. The variable is x. The value is 7. And it's going to be of which function? Var f1 is where I've stored that, of x. And I got negative, flip to this page, 0.8119, which we know to simplify to negative 8.120. That's what reduces down to, and they're always going to say is explain the meaning of f prime. All we're ever going to do when we see a prime, we're going to add the words rate of change. Okay, so f prime is the rate of change of, what is f equal to? F is equal to pounds per, it's the rate of change of bananas. So it's equal to the rate of change of the rate of change of bananas leaving the store. If you want different words, you can use them. Here's our new double rate of change. I've got that prime means rate of change. F is already stored in rate of change. You can put the word acceleration, but you also don't have to. Anytime you see a prime, you can just add an extra rate of change word to the problem. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. Well, and to find out if the number of bananas is increasing or decreasing, I have to look at the rate of change of bananas. The rate of change of bananas is G and T and F of T. G of T is what's coming in, minus F of T is what's coming out. And the words increasing or decreasing are going to, I just look at the positive or negative nature of that. So I'm going to find G of 5, and I'm going to find F of 5. So I'm going to come to my calculator. I'm going to go menu, calculus, rid of at a point. It's going to be at 5. And it's going to be for f2 of x to start with. f2 of x, and hit enter. So I got 0.8229 for that one. And now to find the other one, I don't have to retype the whole thing. I can grab it and just change this to f1. Enter. And I've got, so now if I do 0.8229, the original, that's the bananas coming in minus the bananas going out. I get a negative answer. So I'm going to give them just the information they want. Is the number of pounds of bananas increasing or decreasing? It's decreasing because the rate of change of bananas is negative. You can put down your answers if you want. You could write down 0.8 minus 1.7, whatever that number was. Let me find it. 7051. But you don't need that info as long as you told them it is decreasing. And the last part of the problem says how many pounds of bananas on the display table at time t equals 8. Well, that's going to be a start plus integral of what's coming in minus the integral of what's going out. And it's at time t equals 8. So we started with 50. So we're going to integrate this function from 0 to 8 of the in. That's f2 minus the integral of what's going out. So that would be from 0 to 8 of f1 of x dx. Now I made a mistake here and I kind of did it on purpose. We want to know what's happening with the bananas from time t equals 0 to t equals 8. Well, there's always 50 at the start. Bananas are always leaving between 0 and 12. So that's why I have it here between 0 and 8. That's what we're looking at. But bananas only start entering the store at 3. So this number here needs to be 3. If I wrote this out and just wrote that number wrong, I'll lose a little bit of the problem. So now I'm going to go to the calculator. I'm going to enter this in, 50 plus, and this is why I stored it in the graph so I don't have to keep typing them in. Menu, calculus, integral, 3, and the order you do these in doesn't matter, to 8 of f2 of x dx minus and new calculus integral from 0 to 8 for f1 dx. I'm gonna hit, oh, I forgot the x. I'm gonna hit enter. And I got an answer of 23.3474. That's how many pounds of bananas are there after 8 hours. So I'm going to go back to my graph page here. And I'm going to make sure I round that correctly. The number of pounds of bananas is, so I'm going to write this statement down, equal to 23.34. I'm going to round it to 7. The reason you want both these things written down is if you made a mistake here, at least if you wrote that down, they know you got it right answer, you get at least 3/4 of the credit. So we've done 3 of these types of problems now. I think you kind of see how they're going to go. Remember to write them into your AP packet because you can have this for the test. And I'm going to send this up to you, and I shall see you tomorrow for Kahoot.